Okay, now we're looking at the differential equations found in group 3. So that's where you have both the independent and dependent variable. So let's take a look. First question says use implicit differentiation to find the derivative with respect to x of ln y equals a half x squared. So derivative of the left side is 1 over y dy dx. Right side is just going to be x. Okay? So then if we solve this, dy dx equals xy. So that's an example of a differential equation in terms of both x and y, both the independent and dependent. Now it says determine the integral of 1 over y dy equals integral of x dx. Okay, so what's that going to be? That's going to be ln of y equals x squared over 2 plus c, and you should recognize it. So here, if y is greater than 0, then that's the exact same equation, right? It's the exact same, so the same if c equals 0, okay? How does 1 over y dy equals x dx compare to the derivative you found above? Well, here, if we bring the y to the left, that would be 1 over y. And if we bring the dx to the right, we'd have dx. Okay, so basically, if you have an equation, see if you can, what we call, separate the independent and dependent variables by dividing, okay, or multiplying both sides. Sometimes subtracting or adding, but then you'd have to do some work to get it into a ratio. All right, so use this knowledge gained in the investigation to determine the general solution to this differential equation. So now that means here we're going to multiply through by y squared and dx. Now we're going to integrate both sides. So that's going to be y cubed over 3 equals negative cos x plus c. And then we still want to solve for y. So that's going to be y cubed equals negative 3 cos x plus 3c, okay, which you could call that a different constant. And then cubed root. All right, so that's your function, okay, that has a differential equation dy dx equals sine x over y squared. Okay, so the equation above represents the graph shown below. So now we've graphed it to find the specific solution. So basically the graph here will be based on, now we have to find what c is, right? So based on this graph, we can get more specific. This still has a constant in there, right? Back from up here. All right. So what's a nice point here is pi 3, which is a nice point. The other ones are hard to determine the exact value. Okay, and then substitute it in. Okay, so your c, I might actually go back up to this version here. Or actually, no, because that's not y cubed over 3. I'm going to do that because then we can solve for c easily. So y is 3, x is pi, so c will equal 27 over 3 is 9 plus cos of pi is negative 1. So c equals 8. And then you can substitute back in. Okay, so therefore y equals 3, negative 3 cos 3 times 8 is, is 24. Okay, so that's the specific solution. It says verify with your calculator. You can do that. You can graph that. Okay, so just graph it and make sure it looks the same as the one given there. All right, so the rate of change in the dependent, so this is for group 3, with respect to the independent, so dy dx, is related to both the dependent and independent. The independent and the dependent variable can easily be what we call separated. And so these types of differential equations are called separable differential equations. We don't say group 3, we're just kind of grouping them, but they're separable. So let's do an example. So the gradient, gradient is another word for slope, and they use it a lot in IB. So the gradient of the tangent at each point P of a curve is equal to the square of the gradient of OP. O is the origin. Find the equation of the curve. All right, so general point P. Okay, so, and then the slope of the tangent at each point P of a curve. So the slope of the tangent is dy dx. It's equal to the square of the slope of OP. Okay, so O is 0, 0. So the slope of OP is y2 minus y1 over x2 minus x1. So really dy dx equals y squared over x squared. Okay, so let's separate those. So that's going to be 1 over y squared dy is 1 over x squared dx. And integrate each. So that's going to be negative 1 over y equals negative 1 over x plus c. And again, it doesn't matter which side you put c on. I just always put it on the right. Okay, and then we want to solve for y. So let's multiply through by lowest common denominator. Actually, negative of the lowest common denominator. How about? Okay, so then we get positive x equals positive y minus cxy. And then we want to solve for y. So y equals, got two terms with y. So let's factor out a y. And so that means y equals x over 1 minus cx. Okay, that's the equation of the curve. Next one, differential equation is given there, so it's in terms of x's and y's. Find the equation of the solution curve, which passes through a certain point. So that means we can find a c value, and then the general solution. Okay, so in terms of c, which we can replace to make it a little bit simpler if possible. So part A, so we want to get the y over the left, to the left, so that'd be 1 over y dy equals, and we've got x over x squared plus 1 dx. Integrate both sides. So that's going to be ln of y equals, and then the right side, you don't need to show substitution, but if you want to, you can. That's going to be 2x dx. Okay, you can kind of use that just to help you figure out. It's going to be 1/2 ln of u, which is x squared plus 1, okay, plus c. Now, we don't need absolute value on the x squared plus 1 because it'll always be positive. X equals, so our point is 1, 2. So x equals 1, y equals 2. So let's solve for c. Okay, so c will equal a half ln 2, ln 2 minus a half. So ln 2 from here, then subtract a half ln 2, which is going to be a half ln 2. So back to your equation. Substitute c in. We can simplify that. That's got a common factor of a half. And then you're multiplying, you're adding logs with the same base, so you can multiply the arguments. Okay. And then, really using your log laws, that's going to be the square root of 2 times x squared plus 1. So now absolute value of y equals the root of 2 times x squared plus 1. So y equals plus or minus. But at the point 1, 2, then obviously this would be, so for point 1, 2, this would be the positive, because we have a positive y value. Okay. So back up, we've done some of the work already for part B, the general solution. So we want to get to, so here, this is your general solution, okay? But we want to solve for y. So what's nice here is, some of you have asked about c, is that, can we call it something else? Yeah, you can, okay? So in this case, if we let c equal a natural logarithm, then we can kind of incorporate it into one term based on your log laws. So I'm going to let it be ln of a, okay, where a is greater than 0. We're going to substitute that back in. We can use our log laws. You might think, oh, I could use a half ln a. Yeah, you can. It's just you'll see that when we don't do that, we'll actually have a simplified radicand. Okay, so but it's not wrong to do that. So now ln y equals I'm going to show that as a radical, and then we're adding logs with the same base. That's going to be a product. And so now y equals plus or minus a root x squared plus 1. Okay, so really a was positive there. Now this coefficient could be positive or negative. So you could actually even replace this with another constant where it's any real number. Okay. And last one, it says, for a certain period of about 12 years, the rate of growth of a country's gross national product is predicted to vary between positive 5% and negative 1%. This variation is modeled by that percentage. Notice how it's a trig function, because it's very up and down. It's kind of cyclic. So where t is time in years, find a formula for the GNP during the cycle. So let's call that something. So gross national product. So let P be gross, well, GN, abbreviation, GNP after T years. Okay, so the rate of growth then is dP dt, and that's given as a percent of its current value. So its current value of P. Okay, so dP dt. Now this one, kind of hard to come up with this differential equation, so don't worry too much. Most of them we will be giving them to you. You don't actually have to come up with them, except for the ones that we've done so far in the previous groups. They've been fairly straightforward. This one's a little tougher. So we'll try to give you some hints if you have to make it up yourself. So remember a percent. We don't want to keep a percent in our equation. So what does percent mean? It's out of 100. So that percent of the gross national product. Okay. So now that's our differential equation. So where's our T? It's in here. So so we'll bring the dt over. We'll keep the whole bracket and then bring the P over to the left. I mean, you could rearrange the 100 and stuff like that, but we're going to keep it like this. So 1 over P dP dt. Oh, and I'm going to move the dt. Okay, so integrate that. So that's going to be ln of P. And so we can take each term here. So that's 2 over 100. So that's 1 over 50. So it's going to be 1 over 50 T plus 3 over 100. Integral of cos of a half T. So it's going to be sine of a half T divided by a half, which is times by 2. So you could actually put it like that if you wanted to. Plus C. Okay, so ln. Now, gross national product is always greater than 0, so we don't need the absolute value in this case. Here, take a look. 2 goes into itself once, into this 50. So we could show this as one fraction. Alright. Now, our initial, well, at time 0, we don't know the value of the gross national product, so we'll just call it P naught. All right, so that means time equals 0. We'll have 0 plus sine of 0 is 0. So that's basically, should be ln P naught. So we substitute that in for P. 0 into the right side gives us 0 plus C. So C is ln of P naught. So now we can come up with our equation. So right now, if we were trying to get P by itself, we would have to basically use exponentials right now. So what's easiest is to bring the lns together. So when we subtract ln P to the left, subtracting logarithms, you divide the arguments. Okay, and now we can get the p's together. So now p over p naught is going to equal e to this expression. And so then p is p naught e to the t plus 3 sine 1/2 d over 50. Okay, so now that relates for, you need to know what the gross national product was to start, so P naught, and then based on the time, you can find the nu. Okay, so really the hard part is if you have to come up with the differential equation, but as I said, we'll give you some hints if you do, otherwise we'll actually give it to you. All right, so that's the end of this group.